Hi, good to see you again. Welcome to Block 1, Constructing, Measuring, and Using Geometric Notation, Lesson 8. I'll share my screen. So, in your previous lesson, you learned how to draw and measure reflex angles. In today's lesson, you're going to learn how to identify perpendicular and parallel lines. It's a very important lesson, so pay close attention because you build some really good foundation understanding of these concepts in maths. Remember to like the video, share the video with those you think can benefit. Subscribe to the channel and click on the notification bell so that when new videos are released, you will be notified. Before we start, pause the video and answer the retrieval practice questions in 3 minutes. You can take longer, you can take shorter, you don't have to stick to our timing. Assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. For the first one, you were asked how many degrees are equal to 1/4 turn. 90 degrees is equal to 1/4 turn. Why? A full turn is 360 degrees, so a quarter turn is 360 degrees divided by 4, which is equal to 90 degrees. Question 2, you were asked, look at the line segments. A, which line segment is horizontal? The line segments that are horizontal are CD. Which line segment is vertical? For B, the line segment that is vertical is GH. Okay, let's do some new learning for this lesson. We're going to discuss perpendicular lines and line segments. Now, using a grid, we're going to demonstrate what perpendicular lines are and line segments. So if we use the grid and draw these lines, we have just created perpendicular lines. How do we know? We know this because for a grid, the lines are already perpendicular. But that is not the only way we can draw perpendicular lines. We can draw it like that. If you're not sure whether this line is perpendicular, you can actually use a protractor to measure the angles between this point, that point, and that point. You will see that they are each 90 degrees. We can also draw some like this and like that, even on a plain paper. So you can use set square to draw perpendicular lines, or you can use a protractor to, after you've drawn a line segment, you can use a protractor to mark 90-degree angle and to use a straight line to connect them. So like that. You can also see perpendicular lines that are marked like this using this notation. So this notation shows right angle, so that line, those lines, segments are perpendicular to each other. You also find them in polygons like the triangle. That is perpendicular line, the line segments AB is perpendicular to the line segment AC. All right, let's discuss parallel lines and line segments. Well, on a grid, we can draw parallel lines. These are parallel lines. These are parallel lines. Remember, parallel lines will not meet. These are parallel lines. Now, we use this notation to show parallel lines. So we know that those pair of parallel lines are only parallel to each other. So if we want to show another set of parallel lines, we have to use a notation that shows two arrows. And we can continue the method like that. We can also show parallel lines on plain paper. And we can use the notation to show that they are parallel. So they go in the same direction and they never meet. So take note, parallel lines would travel in the same direction and they never meet. We can also show parallel lines in polygons like this. So this is a parallelogram, and we can show parallel lines in that direction and those other sets of parallel lines in that direction. Here, Mo says parallel lines will never meet. Do you agree? Have a think. Well, let's explore this. If we draw lines continuously, this is what it would look like. And of course, you can see that the lines will not meet. So we'll agree with Mo. It's time for you to practice what you've learned. So pause the video and answer question 1 in 1 minute. Assuming you've paused the video and you've answered question 1, here is the answer so you can mark your work and celebrate your success. So you were asked to tick the parallel lines, and visual inspection shows that these lines appear most parallel than the other lines. So we'll tick these ones. Pause the video and answer question 2 in 1 minute. Assuming you've paused the video and you've answered question 2, here are the answers. We can see that these appear more perpendicular than the others by visual inspection. We don't need at this stage a protractor to verify it, but you may have used a protractor to verify this. So you may have screenshot this sheet, printed it out so that you can have a practice. But these are the perpendicular lines. Pause the video and answer question 3. Now the answer is displayed already. So here you were asked on a grid, draw 2 different pairs of parallel lines. So parallel lines are lines that will go in similar direction and they will not meet. In the same direction, they will not meet. And these lines are parallel lines. Pause the video and answer questions 4 and 5 in 2 minutes. Assuming you've paused the video and you've answered questions 4 and 5, here are the answers. So here you were asked, draw a line that is perpendicular to AB, that's the line there, and CD, and that's the line there. Next, you ask, she says, these are parallel lines because they never meet. Well, is that really true? If we keep drawing the line to the left, you would see that at some point they're going to meet. Okay, let's do some further learning. If we're asked to draw a line segment parallel to PQ, how would we do this? Well, to draw a line segment parallel to PQ, the first step we need to do is we need to mark a point, any point on PQ. Next, we'll take a protractor and we'll mark 90 degrees from that point. So we'll mark another point just above the 90-degree angle or the 90-degree point on the protractor. Why? For a parallel line, the perpendicular distance of all the points from that line to the other line that is parallel must be equal. So the perpendicular distance must be equal. That's why we're doing this. So we'll mark another point and we'll use our protractor to mark 90 degrees. Now, the next thing we'll do is we'll use a ruler to join both points. So at every point in time, the perpendicular distance from this line PQ to the other line will always be equal. But is that the only way we could draw parallel lines? What if we, after we've marked this, let's bring the protractor back. Let's say we decided to mark 60 degrees. Let's say we decided to mark 60 degrees here. All right, from that point. And let's say we decided to mark another 60 degrees from that point. Now, if we mark those points, my question I want you to have a think about and for you to practice, when we join these two lines, these 2 points together, because we made sure they were each at 60 degrees to each, from the line, do you think we would create parallel line? Because each time, don't you think that each of these lines will always have the same distance? So that is for you to investigate. Okay? So that is not the only way. Using the perpendicular distance is not the only way to create a parallel line to PQ. So have a think and practice that. You can see that. Okay. Here is what Rosie thinks. See, she thinks if train tracks are parallel, then it is possible to have parallel curves. Well, we'll agree with Rosie if you think about it, because train tracks actually are parallel. If the train tracks were not parallel, at the curves, the trains would go off the track. But not all curves are parallel, so you can have this which is not parallel, even though it may seem that the perpendicular distance between the lines are equal. It's now time for you to practice what you've learned. So pause the video and answer question 6 in 2 minutes. Assuming you've paused the video and you've answered question 6, here is the answer. So here you were asked, discuss with your partner how you can draw a pair of parallel lines on blank paper. So remember what we did? You draw first a line segment. You mark the parallel notation on the line. Then you take a protractor. You place the protractor on the line segment. Let's say, for example, you call this line segment PQ like we did before. And an easy way is for you to take a protractor and you mark points here, you mark points there, and then you make sure that you place the crosshair of your protractor here and mark an identical 90 degree on the protractor point on top of that point. And then you mark another one there using your protractor, and then you use a ruler to connect those points. Pause the video and answer question 7 in 2 minutes. Assuming you've paused the video and you've answered question 7, here are the answers. Let's discuss them. Here you were asked to complete the sentences. AB is parallel to CD. We can see that. IJ is perpendicular to AB, and we can see that. They're perpendicular. If we continue this line and we continue that line, you'd see that they're perpendicular. And CD, if we continue that line, you would see that it's perpendicular to IJ. EF is parallel to OP. EF is parallel to OP. All right? Of course, visual inspection tells you that they are parallel. And then KL is perpendicular to MN. KL is perpendicular to MN. And you can see that that will form a 90-degree angle with that line. Pause the video and answer question 8 in 2 minutes. Assuming you've paused the video and you've answered question 8, here are the answers. So here you're asked to write the names of all the vertical line segments that are parallel. The names are AF, BC, and DE. You can see that they are parallel. Visual inspection tells you they are parallel. Okay? Write the names of all the horizontal line segments that are parallel. AB, CD, and EF. Write the names of all the line segments that are perpendicular to FE. So lines that are perpendicular to FE would be AF, BC, and DE. pause the video and answer question 9. So here is the answer. Here you ask, draw these different shapes that have two pairs of parallel lines. So different shapes would be square, the rectangle, and the parallelogram. And that brings us to the end of our lesson. So well done for learning about identifying parallel and perpendicular lines. You've also learned that curves can be parallel. That's why your train tracks can work. Well done for sticking around and for learning an important concept in maths. Until next time, take really good care of yourself and bye-bye.